Okay. So this is the easiest one. You cover the inside function and pretend that your thumb or hand, whatever that's covering it, is a variable like x. So when you cover it, it looks like sine of x, right? If you differentiate sine of x, according to this here, it says sine prime is cosine. So you really get cosine of that thing. It's cosine of what I covered. Okay. What did I cover? It's e to the x, right? But the chain rule says you don't stop there. You pull that outside and differentiate it. So pull the thing that you covered, pull it outside and differentiate. Okay? And according to this, we have here e to the x differentiates to e to the x. Therefore, it's e to the x. Okay. Now, these two e to the x, however tempting it looks, you cannot multiply together because this is really cosine applied to e to the x, and then you're multiplying e to the x. So, because it's somewhat confusing, people usually write e to the x in front of the cosine e to the x to reduce this confusion. So, this last step is not necessary, but it's helpful if you have to differentiate twice, or you have to use this for other things. Okay. All right. So in the second example, it's very similar. Again, you cover. You're differentiating sine of what you're covering, and because sine x is cosine x, the derivative is cosine of what you're covering. Cosine the inside function, and you pull the inside function out, and you have to differentiate. But then, when you try to differentiate this is not exactly the same as that. And if you try to think about what kind of structure this has, you realize that this also has an inside function. In other words, if you cover the 2x and pretended that was like an x, then it's exactly that. So this is again a nested function where the inside function is 2x. Okay? So you're differentiating e to the x, e to the x, or e to the what you're covering. So because e to the x differentiates to e to the x, nothing changes. However, the thing that you covered should be pulled outside and differentiated again. So the final answer is this differentiates to 2. It's 2 e to the 2x, okay, and then cosine e to the 2x. And I move these two numbers, number and the function in front of the cosine function because of this, for the same reason I did this. Okay. All right, here. This is a product of two functions, e to the x and sine 2x. You're differentiating a product of two functions, therefore you use what? Is it optional, or do you have to use it? You have to use it. It's not optional. You must use the product rule, which says differentiate only one of them, multiply the other one, plus leave the first thing that you differentiated and differentiate the other one you did not differentiate. So that each individual functions get a hit. Okay. So e to the x prime is e to the x. It's not hard. And sine 2x differentiates to, oh, you look here, it's cosine x. Instead of x, we have 2x, so we know that that's an inside function. So we differentiate it like cosine of 2x, but then you pull out the 2x and differentiate. And finally, you have e to the x sine 2x. This differentiates to 2, so I can put it in front. 2 e to the x cosine 2x. If you want, you can further simplify by factoring out e to the x. That's, I think, a matter of preference.
Can you explain again why you put the 2, the second 2,
This one?
in front of the addition? In front of the addition?
I mean, multiplication is commutative.
Right.
So this 2 I put here, I just put it in front.
Okay.
And the reason is if I put it here, it's kind of ambiguous whether you're supposed to multiply 2 to 2x and then apply cosine, or do you apply cosine to 2x and then multiply 2? Where this really, the way we want to write it is that 2 has to be multiplied after you take the cosine of 2x. In order to get rid of this ambiguity, I want to clarify that by putting the number in front. So usually you put numbers or constants front, and then functions at the end, and you follow these structure. But what was your question? Why I have 2?
Oh, no.
No, that's just from the table.